Welcome guys, welcome. Now we're gonna continue with looking at the graphical approach, looking at the tangents. I want you to master this concept, okay? That is my main goal. Now let's remember this right before we go. What we have learned so far is that the derivative, or rather if I have f of 2 is equals to 6, it means my x is 2 and then the y value is what? Is 6. But once you see it is as f prime 2 is equal to 6, what does it mean? It means the gradient of our tangent line is what? Is 6 at a point whereby x is what? Is 2. It means we only know the x value of that point, but we do not know the y value, but we know that the gradient is 6. Are we clear? Right. Now also we learned that lines that are parallel to each other, they're gonna have the same gradient. Okay, they're gonna have the same gradient, meaning if this is a b and then this is c d, the gradient of a b should be equal to the gradient of c d, so that they can have the same gradient, so that they can be parallel, right? This is for parallel lines, right? And then we also learned that if I have AB here, then I have CD, and then they are perpendicular to each other, right? So this is for perpendicular lines, right? Sorry for the handwriting. So perpendicular lines, we say the gradient of AB multiplied by the gradient of CD would be equal to -1. Okay, so if I know the gradient of AB, that it is maybe 2, I can say 2 times gradient of CD is equal to -1. Then I can get the gradient of CD to be -1/2. Alright. We're gonna look at more problems that are addressing what we have just recapped there, right? But this is crucial to understand in terms of calculus, right? Now let's look at this problem here, right? This is what we have. Wait, we did this problem, isn't it? We did it, just that at that other okay, this is what I did. I took the problem I gave you. It was this one, if you can remember. I gave you this one, and here it was just 4 marks. It is the same problem, but just that instead of using, check them, right? What I was telling you, instead of using y, now they are using what? They are using FRX. Okay, but remember we solved it exactly. We were actually also using FRX when we were solving it, if you can check the previous video, right? Okay, but then it's fine. Here it starts by saying find f prime of x from first principles for 5 marks. Then after that it says determine the equation of a line that is perpendicular to the tangent at A, right? So remember that line that is perpendicular to the tangent will have y is equals to mx plus c. How do you get its gradient? You first have to find the gradient of a tangent. Then after finding the gradient of the tangent, you say gradient of the line times of the tangent give you -1. Then you will get the gradient of the line. Then after that you substitute A into the equation, you get C. Then you get the equation of the line. Okay? If you want the equation of the tangent, after you get the gradient of the tangent, you substitute x and c into this equation to get C. Then you have the equation of the tangent. Alright, so this is a tangent, this is a line perpendicular to the tangent. Alright, so maybe let's just do it, isn't it? Let's just do it more over again. Repeating stuff is not a bad idea, because the more you repeat stuff, that is the more you understand, right? So let's see. First of all, can we try to find the derivative from first principles? You can go back to our previous videos on derivative from first principles and then check how we do them. But I'm gonna try and do it with you here, right? We know that from first principles we need to remember our equation, which which is the lim of f of x plus h minus f of x, all divided by h as h tends to 0. By the way, before I solve this, in our last video we found the derivative of f. It was, we had y is equal to x plus 12 over x. Now we applied the rules to find the derivative. We actually said this, and then we said x times x to the power negative 1. Then we said dy over dx was 1 minus 12x to the power negative 2, which we said is the same as saying 1 minus 12 all over x to the power 2. That was the derivative. Ne? This was the derivative. Now it means using first principles, we must still get this answer here. Okay, so what am I gonna do? I'm just gonna keep this answer very safe. Don't worry, good people. I'm keeping it very, very safe. We'll still have it. I'm just gonna put it somewhere here, even though you won't see it, right? Yeah, you won't see it probably, but then I will take it out at a good time, right? Then we compare with that. So let's continue. What is the first thing we do? We have to find f of x plus h, right? Now how do we find f of x plus h? Where we see x, we put x plus h, right? So we're gonna have x plus h. Since this is x here, right, I put x plus h. Then I say plus 12 divided by x plus h. Because this is x here, I put x plus h, right? So this would be x plus h plus 12 divided by x plus h. Okay, so this is our f of x plus h. Okay, that is our f of x plus h. Then what is our f of x? Our f of x is x plus 12 all over x, right? It is this one here. Let me tell you something, good people. If you want to work on these things as they are like this, you're gonna have problems. You're gonna face problems because you always need to make sure that they are under the same denominator. Okay, so how would we achieve that? How would we achieve that? So this is what we are gonna do. Okay, we are gonna say, okay, maybe let's do it here. For f of x plus h, right, we are gonna say, let's assume that this is all over 1. So let's say we have x plus h all over 1, then plus 12 all over x plus h. Now remember to make things have the same denominator. If you can check our videos on this, we say denominator times denominator. So you're gonna say 1 times x plus h. Then after that you say this multiply by that. You go like this. Okay, so what would be x? So it means you would say x plus h multiply by x plus h. Then after that you say this multiply by that. So you go like this. Okay, so there you would have plus 1 times 12, right? The plus is this one, then you say 1 times 12. So it means for your f of x plus h, what are you gonna have? You're gonna have x times x, which is x squared. And then remember that thing, you can do it, right? Let me just give you the final answer to save time. You're gonna have 2hx and then plus h squared. Then you're gonna have plus 12, right? And then you're gonna have all over x plus h. This is a nice f of x. So we're gonna do a similar thing for our f of x, right? So for f of x, we are also gonna say f of x is equal to x over 1 plus 12 over x. Then what do? We say denominator times denominator, that would be 1 times x. Then you say this times that, right? So that would be x times x. Then you say this times that. Okay, so that would be plus 1 times 12, which would mean that you have what? sorry, which would mean that you have what? You have x squared plus 12 all over x. Okay, this would be our f at x. That would be our f at x. So we're gonna substitute those into the equation of lim there, right? So you're then gonna say the derivative of f would be lim as h approaches 0. Remember, f of x plus h. So you substitute f of x plus h first, right? So that would be x squared plus 2hx plus h squared, and then plus 12, all divided by x plus h. Then you say minus f of x, which is x squared plus 12, all divided by x, right? Then what can you do there? You can then say this is all divided by h, right? That will be all divided by h. Now it starts to get a bit hectic, isn't it? When it's looking like this, it starts to look like very much difficult, but it's not, right? It's not. This is what you can do. Instead of writing divide by h, remember, what can we do there? We can remove that division sign, right? We can remove it and write it differently, and just say, especially we do this when we have fractions, isn't it? So we're just gonna say divide by h instead. All right, then you simplify in the brackets. You're gonna want to make sure that in these brackets you have one denominator. So what are we gonna do? You're gonna say lim as h approaches 0. Then you're gonna say a long division sign, right? A long division sign. Then you say this denominator times that denominator, like we just did. So that would be x plus h multiplied by x. Then you say this multiplied by that, right? So you'd have x into x squared plus 2hx plus h squared plus 12, right? Then you then say this multiply by that, right? In between there is a minus, so you say this, right? X plus h multiplied by x squared plus 12, right? Then all of that is divided by h. Sure. It's a lot, isn't it? It's really a lot, but let's continue working, right? I believe in you and I. Okay, so now we're gonna say, what I'm gonna do is that I'm just gonna take only this part, okay, to a clean page. Okay, so this is what we have, right? So remember, this divide by h, we're gonna remove that division sign, right? Then what are we gonna say? We are gonna say multiply by 1 over h. Remember, this is h over 1. So when we multiply by the reciprocal. We swap the numerator and denominator like this. So what do we have? It means we will now have the lim of before I multiply here, maybe let's try to see if we can simplify inside, right? So x times x squared, that would be x cubed. X times 2hx, that would be 2hx squared. Then x times h squared, that would be h squared x. Then x times 12, that would be 12x. Then we're gonna have minus. Then we say x times x squared, that would be x cubed. And then x times 12, that would be 12x. And then h times x squared, that would be hx squared. And then h times 12, that would be 12, right? That would be 12h. Then we close the brackets, right? Then we also close those brackets there. We say that is divided by x times h, that will x times x, that will be x squared, and then x times h, that will be hx. Okay, now don't forget that all of this that you see here is divided by all of that is divided by, or rather it's multiplied by 1 over h, right? Where does this squared come from? Let me check. X times that is that, x times that is 12x, and then h times that is hx squared, right? So that 2 is there. Let's remove it. Okay, so this is what we have so far, right? As our h approaches 0, then what can we do? We can just multiply h inside. 1 times that, the denominator remains the same, then h would be there. So what would we have? We say lim, you can simplify, right? That would be x cubed plus 2hx squared, and then plus h squared x, and then plus 12x, right? And then we say minus x cubed, right? And then minus 12x, and then minus hx squared, then we say minus 12h, right? Minus 12h, all divided by, you say h times this, so this h is going to multiply this whole term, okay? So you say h times h squared, x squared, that would be hx squared. Then you say h times this, that would be okay, wait, sorry, let's actually not maybe simplify them, okay? Because remember, h has to cancel, h on top and h on the bottom. So for that to happen, let's leave h here and just say it's gonna multiply x squared plus hx, okay? This is what we have. So just a bit of recap before I go further, right? Don't get lost. We say this times that, we get that. Then we say this times that, we get this. Then we say this times that, we get this. Then remember, we divided by h. Now we're gonna say multiply by 1 over h. Then after that, what do? I was just multiplying x inside here. Then here I just simplified these two brackets here, multiply by 1 over h, right? Then what did I do? Remember, when you have a fraction times a fraction, we say numerator times the whole numerator, denominator times the whole denominator. So here the numerator, which is 1, times this numerator, this big numerator here, this big numerator will not change because it's multiplied by 1, so it remains as this big thing here. Then h multiplied by the denominator is this, h multiplied by this denominator, okay? So now I just have to look at for like terms, just like we do whenever we are solving for a from first principles. We always look for like terms. So x squared will cancel negative x squared, 12x will cancel negative 12x, h squared x, let's see, then that is it. Let's see, negative hx squared x, then here we have 2hx squared x, okay? Okay, that's fine, then we have that. So we can simplify on top there, right? So we can now say we have lim, and now this and that, they are like terms. So we're just gonna add the numbers in front. 2 minus 1 is what? Is 1. So we just have hx squared x. Then here h squared x, no, that was hx squared, right? So here h squared x, right, which is h squared x, we still have it. Then we have negative 12h, all divided by, right, all divided by h into x squared plus hx, right? Now as h approaches 0. Now someone might say, what happened to this? Good people, check what we did. This one here and that one there, right? This is hx squared, this is hx squared, so they are like terms. So just say 2, right? Then you say minus the 1 that is here. There is a 1 but they don't write it, so that 2 minus 1 gives you 1. 2 minus 1 is 1, so I wrote 1 hx squared. Okay, this is hx squared. Then this one here is the one that was always there, it's back there, right? So this is the same as that, okay? Then after that, this is the same as this. Okay, it's the same as this. So I hope you are not lost there, right? Don't worry. I know my students, when you have a lot of numbers, they tend to get lost somewhere, and I try to make sure that I don't lose you at all costs. So now we have is equal to lim, then we have h approach 0. Now here we can take h as a common factor like we're always doing. So we say this, and then we have if I take h, right, I'm left with x squared. Here if I take h, remember h squared is h times h. If I take 1h, I'm left with 1h. Okay, h squared, if I take 1h, I'm left with 1h. Here if I take h, I'm left with negative 12. Okay, then that is divided by h into x squared plus hx, right? Then what can we do now? We can divide here. Then it means now what do we have, right? So it means we now have this would be equal to the lim of as h approach 0 of x squared plus hx minus 12 all divided by x squared plus hx. Okay, so remember, after cancelling h and h, most of the times we now substitute. So that's what I'm gonna do now. We substitute and say x squared plus 0x minus 12 all divided by x squared plus 0x. Where I see h, I'm just putting 0 there, right? And then I no longer write lim. Okay, so what will we have there? We'll now have x squared minus 12 all divided by what? By x squared. Now remember, just like we said, if you have 2 plus 4 divided by 2, this is the same as saying 2 divided by 2, right, plus 4 divided by 2. So here is the same as saying x squared divided by x squared minus 12 divided by what? By x squared. Now what is x squared divided by x squared? That is 1 minus 12 all over x squared. So this is our derivative there, which is exactly the same answer as, ladies and gentlemen, look at it properly. 1 minus 12 over x squared, 1 minus 12 over x squared, 1 minus 12 over x squared, 1 minus 12 over x squared. Voila, 1 minus 12 over x squared. Okay, so that is it there. So now for this one, good people, I believe I already did it on our previous video. Please forgive me. I'm not gonna go through it again. Just check the previous video on this, and then you'll be able to get it right, because I just want us to look at another one. Or should we do it? I don't know. I got voices in my head saying, do it again, do it again, do it again. Okay, no what, let's do it. Let's do it again. We can do this, good people. So they want the equation of a line perpendicular to the tangent to the curve at that, right? We already know the derivative now. So we got it through using first principles. So this is what we're just gonna do, right? We're gonna quickly do it and say, for the line, right, we know y is equals to mx plus c, but we don't know the gradient of the line. What about the gradient of the tangent? Do we know the gradient of the tangent? Well, at this point x is 2, right? X is 2. So we need to know what is the derivative at x is equal to 2. So remember, the derivative of f is 1 minus 12 all over x squared, right? So we want to know what is the derivative at 2. That would be 1 minus 12 all over 2 squared, right? Then that would be the derivative at 2. That would be this is 12 divided by 4, right? It gives you, so you get that the answer is negative 2, right? The answer is negative 2. So this means, therefore, the gradient of our tangent is negative 2 at x is equals to 2, right? So we know the gradient of the tangent. Now, since we know the gradient of the tangent, so that these things are perpendicular, the gradient of the tangent must be, when you multiply with the gradient of the line, they must give us -1, right? So the gradient of the tangent is -2, and then times the gradient of the line, which is equal to -1. So it will mean that when you divide by -2 both sides, the gradient of the line would be equal to half. Okay, now that we have the gradient of the line, we can write our equation as y is equals to half x plus c. Now we need y and c. We already have the point, right? We already know that x is 2 at the point. We just need to know what is y if x is 2 at that point, right? So to get y, right, to get y at x is equals to 2, let me just do it here, right? Or maybe let's go down. So to get y, I'm gonna say y, okay, sorry, I'm gonna say, I know x is what? X is 2, right? So we have to say f of 2. Let me just write f of x here. F of x is x plus 12 over x, right? It's x plus 12 over x. Now f of 2 means where I see x I put 2, so I'm gonna have this and then that, so it will be 2 plus 6, which is 8. So f of 2 is what? 8. It means when x is 2, y is 8, right? So I substitute that into this formula. Where I see y I put 8, and then where I see x I'm gonna be putting what? 2, then to get c. So we have half of 2 is 1, and then plus c. Then therefore when you take that on that side, you have 8 minus 1 is equal to c. Therefore your c would be 7. So therefore y would be half x plus 7. But this answer is not the same as the one we got before. So let me actually check the question we had before. Okay, it was not this one. How is it different from this one? It's not this one. Which one is it? I think it's this one, maybe. Yeah. No. My goodness, I think I forgot where I got that question. Okay, no, it's fine. It's fine. So this is the equation of the line. Okay, that is the equation of the line. Okay, so let's move on. Let's see if we cannot do this one. Okay, we already did it. Oopsie. Let's see this one here, because I think I had nice. I just have 2 more questions on graphical application looking at tangents. Then we move on to the cubic function, right? Then after cubic function, we do optimization. Then that will be it for calculus, especially for grade 12 in essay. All right. So how do we solve this one? We are told that g of x is equals to -8x plus 20 is a tangent. Wait a minute, let's stop there. They say this thing is a what? Is a tangent. Good people, a tangent is a straight line, right? A tangent is a what? Is a straight line. And the equation of a straight line is y is equals to mx plus c. But there is no harm in writing this thing as g of x is equals to mx plus c, because y is the same as g of x. Okay, so we are told that the equation of the tangent is grx is equal to -8x plus 20. What does this tell you? It means the gradient of the tangent is how much? It's -8. Do you see that? I just wanted you to see that. So here we said they say it's a tangent to this function f. Your f at x is what? Is x cubed plus ax squared plus bx and then plus 18, right? So and then they say at x is equals to 1. this one here, right? So when they say at x is equals to 1, what does that remind us? It means for this graph of f, if I were to say, right, if I were to say f prime of 1, then the answer would be what? Would be negative 8. Okay, because the gradient of the tangent is negative 8 where at x is equals to 1. Then they want the value of a and b. Okay, so we don't know a, we don't know b. This question here, right, it directly relates to cubic functions, but just remember we are working the same way. Okay, so what are we gonna do here? First of all, we have to find the derivative of f. The derivative of f is here. Remember, you're gonna say 1 times 3, which is 3. Then you say the exponent minus 1, you get 2. Then here you're gonna say a times 2. Whatever is here times whatever is there, right? So a times 2, that will be 2a. Then you say exponent minus 1, that is x. Then here the exponent is 1. I'm just gonna take the number in front, the coefficient, which is b. And then the derivative of a number or a constant is 0. So now that I have the derivative of f, I know that the derivative at 1 is negative 8. So let me substitute f prime of 1 here, which means where I see x I put 1. I'll have 3 into 1 squared plus 2a into 1 and then plus b. So it means f prime of 1 would be what? Would be 3 plus 2a and then plus b. But I already know that f prime of 1 is negative 8. It means here I should have negative 8 is equal to that thing there, 3 plus 2a plus b. All of this thing here, what does this mean? It means all of this must be equal to negative 8 because f prime of 1 is negative 8. So all of this thing here must be equal to negative 8. That's what we are saying here. Okay, so we still don't have a, we don't have b. So whenever you don't have two unknowns, you know that you'll be dealing with simultaneous equations. So you're just gonna call this equation number 1. Okay, we're gonna call it equation number 1. Now what else can we do? Well, the tangent, if I were to draw the graph of f, right, let's say this is the graph of f, right, somewhere there along there we have a tangent here. Let's just say it's this point. We have a tangent here, right? Now that point there, the coordinate is x is 1. I do not know the value of y. I can just call it f of 1 because I don't know the value of y. But the gradient of the tangent here, right, the equation of that tangent is y is equals to negative 8x plus 20. Remember, y is the same as grx, right? Right, it's the same as grx. So this is the equation here. Since this is the equation of this line, if I substitute 1 here, I should get the y value here, right? You must know that this point, it belongs to the equation of a tangent, and also it belongs to f at x. Okay, so what does it mean? If I were to substitute x as 1 here, the answer that I get must be the same as when I substitute x as 1 here on f. Okay, so when you substitute x as 1 here on the equation of this tangent, right, this is our tangent here. If you substitute 1, you should get the y value here. So you say g of 1 is equal to negative 8 into 1 and then plus 20. Okay, plus 20. So that would be negative 8 plus 20, which is what? 12. That is g of 1. So it tells you that here the y value is what? The y value is 12 here. Okay, when x is 1, the y value is 12. Now that I got 12 here, if I substitute x as 1 into this equation of f, I must also get 12. So this is what I'm gonna say. I'm gonna say, if I say f of 1, then substitute it here to say 1 cubed, and and then plus a into 1 squared, and then plus b into 1, and then plus 18. I would get that my f of 1 is equal to 1 plus a plus b, and then plus, sorry, this is 18, plus 18 there, this is plus 18. So what do we have there, right? So all of these, remember, since f of 1 is actually 8, since when I substitute x here like I did, what answer must I get? I must get that the y value is 12, right? Because when x is 1, y is 12. I must get that this thing here gives me 12. So that leads me to my second equation, whereby I'm gonna say this f of 1 should be equal to 12, and then I say what is 1 plus 18, that is 19, and then plus a plus b. So this leads me to my second equation. Then now I can just solve for a and b. Alright, if you have another way of solving this, please, you are more than welcome to share with me in the comment section below. Alright, so now I'm gonna solve for a and b. The best way to do this is use elimination method, right? But I know that there are my students who struggle with that, so I'm just gonna do substitution on that. Okay, so I'm gonna say now I can make a subject of the formula here or b subject of the formula here. Let's say from equation 1, right? From equation 1, I'm gonna say b is equal to, then I'm gonna take everything to join negative 8. So I'm gonna have negative 8 minus 3 minus 2a. Alright, because this will be negative that side, that will be negative that side. Then I'm left with b. Then that b, I substitute it in equation 2, right? So I'm gonna say substitute, right? I'm gonna say substitute b in equation 2, right? So that we have 12 is equal to 19 plus a, and then plus, where I see b, I'm gonna put negative 8, right? Negative 8 minus 3 minus 2a. Okay, so let me just simplify that. I have 19 plus a, right, plus, what is negative 8 minus 3 is negative 11 minus 2a, right? So that will be 12 is equal to, okay, it's equals to 19 plus a, right? And then positive times negative is negative, positive times negative, or is it negative 11? Then positive 1 times negative here, that will be negative 2a, right? So now that I have something like that, I should then say a minus 2a, which means 1 minus 2 is negative a. 19 minus 11, that will be 8, right? So therefore, if I take a this side, then make 12 join 8 that side, then I would have 8 minus 12. So therefore, my a should be negative 4. And then, now that I have a, therefore, our b would be negative 8 minus 3 minus 2 into negative 4, right? From this equation there. So therefore, b would be negative 11 plus 8, right? Which would be negative 3. So that is your a, that is your b. Alright, I hope that was clear. So just remember there, what did we do? First of all, given the equation that told me that the gradient of the tangent is negative 8. Now, since I'm told that this is at x is equals to 1, then I therefore know that f prime of 1 must be negative 8, because the gradient of the tangent is negative 8. Therefore, I must say the gradient at 1 is negative 8, because the derivative is the gradient of a tangent at a certain x value. Okay, so now I substitute that. I find the derivative of f as it is, then I substitute 1 so that I get this. then I know that all of these must be equal to negative 8 because f prime of 1 is negative 8. Then after that, what do? I know that x is 1, so I use the equation of the tangent to get the corresponding y value, which is 12. Okay, so I know that by getting 12 here, when I substitute this 1 in the equation of f, I must also get 12. So when I substitute 1 in the equation of f, I must also get 12. That is why I said all of these must be equal to 12. Right, then I got two equations. Then after that, we just solve simultaneously and we find a and b.